Hi, Assalamu alaikum. I'm Muhammad Ashiful Islam Sajid. I'm on the behalf of Group 9. So, this was our objective um, for our project named Brain Tumor Segmentation. Our objective was accurate and precise detection of tumor that will tell us which one is tumor segmentation and which is do not, and fast and efficient computer timing and proper segmentize of our tumor resume from the other segment, which we will detect from our MRI images from our dataset. So the instruction brain tumors always using segmentation process. These technologies allow for a more accurate and detailed understanding of the location and the behavior, and that would give a improvised and improved situation of a patient's outcome. And brain tumor segmentation is the process of identifying and separating brain tumors, which is a tissue sample, and brain tumor segmentation identifying and separating brain tumors from others in a tissue sample and their behavior as well. Analysis of brain tumors. Importance of spatial awareness. Spatial awareness of brain tumor is crucial in understanding their behavior and developing effective treatments. And the segmentation process allows dividing an image into a multiple segment. In that case, we are using MRI images from a dataset, and each represent a distinct object of a feature. And this was our methodology from the BRATS dataset 2023. This is the picture of T1, T2C, T1C, T2 flare, and crown tooth. And for the data preprocessing tools we use are TensorFlow, Babel, TensorFlow's Keras API, and NumPy, Matpylab, Skitlearn, and Julog. For the data processing, in the conversation we use the 2D arrays convolution layer of 3D images. Ordinal 3D images were converted into 2D arrays, and each row and 2D array represent a 3D pixel or voxel. And for the data characteristic, we used a BRATS 2023 datasets with 1251 images. Each class has T1, T1C, T2 flare, and mask. Excluded T1 images for segmentation and combined the other of the T1C, T2 flare image into one volume. And normalization, for the normalization we applied to each pixel independently. Pixel values range from 0 to 1 computational efficiency. Image were reverted to their original shape. And for the data preprocessing, we are using the computational complexity and focusing on relevant brain regions. And the combination of images, all images were combined into one volume. Input shape become this one. And for the mask filtering, we annotated mask had 4 labels like insert 80, 80, and 0. So for the final selection, after preprocessing, we select 1,151 images from 1,251 images for model training based on criterion of having at least 1% of useful volume with 0 labels. For the methodology, we are using 3D unit architecture, large training dataset, unit from kernelized initializer, 3D unit architecture, and so on. This is our model architecture. If we can see that we are converting 2D arrays into 3D images, and this is our convolution 3D, which is 1 into 1 into 1. Okay, this is our training and validation curves. So in the training and validation curves, we can see that the more we training our dataset, the more validation meanwhile is going to be accurate. So this is dataset before cleaning, and this is dataset after cleaning. After cleaning, we see that we are using plot and subplot to segmentize the tumor from the brain. So in result, we can see that the loss reduction of the data accuracy and the accuracy improvement, and the interaction over union score. So this is our final result that we have already showed in our collab code. So this is our references for our this project. Thank you.